Have you ever wondered how Google translates an entire web page to a different language within seconds? Or how your phone gallery groups images based on their location? All of this is a deep learning product. But what exactly is deep learning? Let's discuss this interesting topic today. Welcome to AI Tech Vision. And for this video, we'll be talking about deep learning and what it is all about. But before that, make sure to subscribe to our channel and turn on the notification bell so you'll get updated on our future uploads. It would also be nice to give this video a like and share it with your friends. Let's start with the introduction of deep learning. We live in a world where deep learning algorithms constantly surround us for better and for worse. From social network filtering, to driverless cars and movie recommendations, and even from financial fraud detection to drug discovery to medical image processing. The field of deep learning influences our lives and our decisions every day. Deep learning is a type of machine learning, ML, and artificial intelligence, AI, that mimics the way people gain certain types of knowledge. Deep learning is a vital component of data science, which incorporates statistics and predictive modeling. It is highly useful for data scientists to gather, analyze, and interpret huge amounts of data. Deep learning makes this process easier and faster. At its easiest, deep learning can be thought of as a way to automate predictive analytics. However, while traditional machine learning algorithms are linear, deep learning algorithms are stacked in a hierarchy of increasing complexity and abstraction. Deep learning is inspired by the way that the human brain filters information. Let's see how it works. At its core, deep learning depends on iterative strategies to teach machines to imitate human intelligence. An artificial neural network carries out this iterative strategy through some hierarchical levels. The initial levels help the machines learn basic data, and as the levels increase, the data keeps building. With each new level, machines pick up advanced data and combine it with what they had learned in the last level. At the end of the method, the system accumulates the final data, a compound input. This data passes through some chains of command and contains a resemblance to complex logical thinking. Let's break it down further with the help of an example. Consider the scenario of a voice assistant, like what you might have on a smart speaker, to see how it uses deep learning for natural conversation experiences. In the initial levels of the neural network, when the voice assistant is fed data, it'll try to identify voice changes, pitches, and more. For the higher levels, it'll pick up data on vocabulary and add the findings of the previous levels to that. In the following levels, it will analyze the prompts and combine all of its conclusions. Finally, for the topmost level of the hierarchical structure, the voice assistant will have learned enough to analyze dialogue and deliver a corresponding action based on that input. Now the question is, how do neurons work? When the input nodes are provided with data, each node is allocated a value in numerical form. Nodes with higher numbers have more activation value. And based on the transfer function and connection, quality nodes exchange the activation value. Once the nodes get the activation value, it calculates the complete amount and modifies it according to the transfer function. The next step is applying the activation function, which helps the neuron decide if a signal must be passed. After the activation process, weights are allocated to the synapses to design the artificial neural network. Weights are crucial for instructing an artificial neural network, ANN, on how to operate. Weights can be adjusted to decide the extent to which signals can be passed. Activation weights are regularly changed while preparing an artificial neural network. Following the activation process, the network comes to the output nodes. Typically, the step acts as an interface between the user and the system. The output node translates the data for the user to understand. Cost functions compare the expected and actual output to assess the model performance. Depending on your requirement, you can select from a range of cost functions to decrease loss function. A lower loss function will result in a more precise output. What have you learned from the video so far? Let us know in the comments section. And don't forget to leave a like and subscribe to the channel for watching more informative content in the future. Two types of propagations are usually used in deep learning. Number one is back propagation and backward propagation. It is a strategy of calculating error function gradients in accord with the weights of the neural network. This process of backward calculation helps in eliminating the erroneous weights and reaching the specified goal. Number two is forward propagation. It is a cumulative method of reaching the goal output. In this method, the input layers process the information and propagate it forward through the network. The errors are calculated once expected results are compared with the outcome values, propagating the information backward. After adjusting the weights to reach the optimal level, the network can be tested for the outcome. Another very important concept involved in deep learning is called deep learning neural networks. It is an advanced machine learning algorithm known as an artificial neural network, which underpins most deep learning models. As a result, deep learning may, in some cases, be referred to as profound neural learning, or deep neural networking. Neural networking comes in different forms, including recurrent neural networks, convolutional neural networks, and fake neural networks, and each has benefits for particular use cases. However, they all function in somewhat similar ways, by feeding information in and letting the model figure out for itself whether it has made the proper interpretation or decision about a given information element. Neural networks include a trial and error process, so they require massive amounts of data on which to train. The model's first few iterations include somewhat educated guesses or unstructured data on the contents of an image or parts of speech. Unstructured data can only be analyzed by a deep learning model once trained, and comes to a satisfactory level of accuracy. But deep learning models can't train on unstructured data, so neural networks become well known only after most enterprises grasped big data analytics and gathered huge stores of data. Now let's see how to train deep learning models. There are 3 common ways people use deep learning to perform object classification. Number 1 is training from scratch. To train a good deep network from scratch, you assemble a very huge labeled dataset and design a network architecture that will teach the features and model. This is often good for new applications or applications that will have a huge number of yield categories. This can be a less common approach because with the huge amount of information and rate of learning, these networks ordinarily take days or weeks to train. Number 2 is transfer learning. Mostly deep learning applications use the transfer learning approach, a process that includes fine-tuning a pre-trained model. You can start with an existing network such as AlexNet or GoogleNet and feed in new data containing already obscure classes. After making a few tweaks to the network, you can now perform a new errand, such as categorizing only dogs or cats rather than 1,000 different objects. This also has the advantage of requiring much less data handling thousands of pictures instead of millions, so computation time falls to minutes or hours. Transfer learning needs an interface to the internals of the pre-existing network, so it can be surgically enhanced and modified to the new task. MATLAB has tools and capacities designed to help you do transfer learning. Number 3 is feature extraction. A marginally less common, more specialized approach to deep learning is to use the network as a feature extractor. Since all the layers are entrusted with learning certain features from pictures, we can drag these amazing features out of the network at any time amid the training process. These features can then be utilized as input to a machine learning model, such as support vector machines, or SVM. So why is deep learning important? To say deep learning is important is to say nothing about its developing popularity. It contributes intensely towards making our daily lives more helpful, and this plant will grow in the future. Whether it is parking assistance technology or face recognition at the airport, deep learning is fueling a part of automation in today's world. However, deep learning's pertinence can be connected most to the fact that our world is creating exponential amounts of data nowadays, which needs structuring on a huge scale. Deep learning uses the growing volume and availability of data to achieve precise results through iterative learning models. The repeated analysis of huge datasets eradicates errors and discrepancies in findings, which eventually leads to a reliable conclusion. Thus, deep learning will continue to impact both business and personal spaces and create many job opportunities in the future. The future is full of potential for anybody fascinated by deep learning. The most surprising thing about a neural network is its ability to deal with tremendous amounts of disparate data. That becomes more and more important now that we're living in an era of advanced smart sensors, which can accumulate an unbelievable amount of data each second of each day. It's estimated that we are currently producing 2.6 quintillion bytes of data every single day. Typically a gigantic amount of data. Whereas traditional computers have trouble dealing with and drawing conclusions from so much information, deep learning really gets to be more effective as the amount of data grows bigger. Have you enjoyed this video? Then leave us a like. You can also comment your thoughts down below about deep learning and something else you want to hear from us. Also, don't forget to subscribe to this channel and turn on the notification bell so you'll get updated for our future uploads. Once again, this is AI Tech Vision. And that's all about deep learning. For now. Thanks for watching.